Welcome back all my aspiring mathematicians. This is the channel where you will learn a lot about math and help you to get over your phobia if you happens to have a phobia. But if you don't have a phobia for math, then guess what? I'm here to boost your energy when it comes to math and maybe help you to achieve that ultimate goal that you're looking for and get rid of any doubts that you may have about math. Have you ever left a math class with doubts swirling in your head because what the professor or teacher just explained to you about the remainder theorem or the factor theorem, you simply don't get it? But guess what? I'm here to break it down to you in the simplest format. For instance, at the end of the math class, you come together with a group of your friends and you so happens to have 13 mangoes in your bag and you decide to share them with your 4 friends. So now it's 5 of you that you need to share these 13 mangoes with. But you need to share them evenly. Because it's only 5 of you and you have 13 mangoes, you're not going to be able to share them equally where each person gets the same amount of mangoes. So you will notice that of the 13 mangoes, each individual will get 2 mangoes each, but then there will be a remainder. That remainder is a 3 mangoes. So you already had 5 groups of 2 mangoes and 3 that are left. This will take you to the remainder theorem. The remainder theorem states that if a polynomial p of x is divided by x minus c, then the remainder r is equal to p of c. This simply means that you will have a remainder left after you have divided your polynomial, which is p of x, by the divisor, which is x minus c. You're still with your group of friends. And so one of your other friends took out a bag that contains 15 peaches. Now that friend is going to divide those 15 peaches amongst all 5 of you. You will notice that you will be able to equally have the same amount of peaches. Each of you will end up with 3 peaches. This will lead you to the factor theorem. The factor theorem states that if you have a polynomial p of x has a factor x minus c, if and only if p of c is equals to 0. Meaning that when you have that polynomial and you divide it by the divisor, your remainder is 0. When you evaluate that polynomial with the c value, you will end up with 0. That simply means that the p of c is equals to 0. Now, what is a polynomial? A polynomial can be classified as a monomial, which would have 1 term, a binomial, which would have 2 terms, or a trinomial, which would have 3 terms. But once you have more than 3 terms, you no longer have to classify it, you just simply call it a polynomial. Now, a polynomial function is usually in the form of a sub n x raised to the nth power plus you're going to minus 1 from that sub n x minus 1 from the exponent. Now, all of that is going to be added and you will end up with a sub 0. Now that a sub 0 is going to be your monomial constant, meaning that that is a number that is going to stand alone by itself. The coefficient here would be a sub n and a sub n minus 1. The leading term would be a sub n x to the nth power. Let's dive right into the lesson on how you can apply the factor theorem and the remainder theorem. If you are using the remainder theorem, it is easier to use a synthetic division. If you don't remember how to divide a polynomial using the synthetic division, I suggest you go back and watch my video on how to divide a polynomial. The synthetic division is easier than the long division method. So now let's get into our first example. So our first example here is p of x is equal to x cubed plus 21x minus 157x plus 135. You're going to find P of 1 using the remainder theorem. Use your synthetic division, and you must note that you're going to use P of 1. So you're going to use 1 outside the synthetic division. Look for your terms here. You know that they're all in descending order. It is written in standard form, so you can go ahead. This is 1 in front of here, invisible 1. This is 21. This is minus 157. And this is 135. Have to first bring down the 1 here. 1 times 1 is going to be 1. And you're going to add. 1 plus 21 is going to be 22. 1 times 22 is going to be 22. You're going to bring your number here. And so you're going to add these, and you will get negative 135. 1 times negative 135 is going to be negative 135. You notice here that you have 0. Now you have your 0 there. Now what does that mean? This simply means that this is your remainder, which is 0. This is going to be your number. This is going to be your x value, and then followed by your x to the second power value. So once you have a remainder 0, then we now need to test our remainder theorem. Since we have the 0 as our remainder, this simply means that x minus c is a factor of the polynomial that is given to you. In this case, x minus 1 is a factor of the polynomial. So let's test p of c and see if we will get it to be equal to 0. So let's first write our polynomial that's given to you. P of x is equals to x to the third power plus 21, x to the second power minus 157, x plus 135. So we need to do now P of 1. So when I substitute my P of 1 there, I need to do my math, and I'm going to use my order of operation so that I am doing it properly. So P of 1, 1 to the third power is going to be 1 plus 21. You must do your exponent first. So this will be times 1 minus 157 over here plus 135. So P of 1 is equals to 1 plus 21. And we can go ahead and do the math over here and combine these, and we will have negative 22 here. So this is now P of 1 is equals to 22 minus 22. So P of 1, therefore, P of 1 is equals to 0. Now, you notice here our remainder was 0. P of 1 equals to 0. We will conclude now and simply say that since P of 1 is equal to 0 and our remainder is equals to 0, therefore we can say that P of 1 is equal to our remainder. Or you can simply say P of C, but in this case it was P of 1 is equals to C. So this means that the factor theorem holds here, right? And P of C is one of the factors of the polynomial. This is a remainder theorem here, which also means that for the remainder theorem to hold, whatever you have for your remainder, which is R, is going to be equals to P of C. So for the factor theorem, we can say that x minus C is equal to P of C. Meaning that whatever factor we have here is going to be equal to what we are going to have for the value when we do P of C. And in case we did P of C with a 0, here is your 0. So therefore you can look at this, and because we know it's P of 1 that we did, we can simply also conclude that x minus 1 is equals to P of 1. And we can state now that the factor theorem holds for this, because once you have 0 as your remainder, then you know that the factor theorem holds here, because x minus 1 in this case is a factor of the polynomial that is given to you. Now, since x minus 1 is one of the factors, you can go ahead now and find the other two factors. And I love to extend everything, as you know me. Since we have our quotient here, this would be our quotient. We can rewrite it as x squared plus 22 minus 135. That is going to be your quotient. Remember, you have no remainder here. And remember, one of the factors is x minus 1. So we can go ahead now and factor this out. In order to factor this out, you are going to find the factors of 135 such that when added is going to give you 22. The factors of 135 is going to be 27 and 5. Because you have 27 and 5, one of the factors have to be negative and the other has to be positive. In this case, because your middle term is a positive number, then your biggest number of your factors should be positive and the smaller one is going to be negative. So now you can use that, and we can write this as two sets of binomials. So you can write it as x plus 27 and the other one is x minus 5. We can split these now and we can say x plus 27 equals 0 and x minus 5 equals 0. So then x would be equals to negative 27, and for here x would be equals to 5. The three factors are x minus 1, x plus 27, and x minus 5. If you want to go further and you want to know more, I can even go further and you can identify your zeros. And we can also include the other factor which we had in the original problem, which would p of 1, which would be x minus 1 would be our other factor. And then this we can write as these are the factors of the polynomial. These are the factors. As you know, I like to give variety, because variety is the spice of life for me, and I like to give variety. So I'm going to give you another example now where this one will illustrate where what if your remainder is not 0. Because you notice when the remainder is 0, the factor theorem comes into play, because now P of C is going to be equal to 0. So let's get right into it. We are given another problem to work with. P of x is equals to 2x to the 5th power plus 3x to the 4th power minus 2x to the 3rd power plus 7x plus 3. And we are going to find P of negative 2 using the remainder theorem. So off the top, as I told you before, you start out with your synthetic division and use that first. So step 1, we're going to use the synthetic division and we're going to set it up. Our negative 2 is going to come here. And I'm going to place 2. We have to look at the exponents to see if any exponent is missing. Yes, we have to put an exponent of 2 there, which would be 0x to the 2nd power. So we have 2 here, 3, then we have negative 2, then we have our 0, then we have 7, and then we have our monomial constant, which is 3. So for the synthetic division, we always have to start off first by bringing down our 2. So negative 2 times 2 is going to be negative 4. We are going to add these, and that will give you negative 1. Negative 2 times negative 1 is going to be a positive 2. And this will be 0. Negative 2 times negative 2 will be 0. And this will also be 0. And negative 2 times 0 will also be 0. This will bring down 7 when you add that. And negative 2 times 7 will be negative 14. When you add negative 14 to 3, you are going to get negative 11. You will now notice that because you have negative 11 here, this negative 11 is going to be your remainder. This 7 is going to be your number. This is going to be your x term, your x to the second power, your x to the third power, and this is going to be your x to the fourth power. Since you have negative 11 as your remainder here, we are now going to test negative 2, right, into our polynomial to see if we will get the same value that we got here for our remainder. Remember now, the remainder theorem is that whatever our remainder is, it must be equal to p of c. You can write out your polynomial. I'm going to start with p of negative 2. So I'm going to have 2 and I'm going to replace it as I go along with our value. I'm going to replace my value plus 7 plus 3. So let's put in my negative 2 here. And let's do our math to simplify this. 2 times, we always do what's in the exponent first. So negative 2 to the 5th power. Off the top, I can show you a trick. Since you are raising a negative number to an odd exponent, your answer here must always be negative. And then you can go back now. Off the top, we know that 2 to the 3rd power is 8. And then 8 times 2 is 16. And 16 times 2 is 32. So this would be negative 32. And then you have your 3 here. And negative 2 to the 4th power, because it's a negative value and the exponent is an even number, then you're going to have a positive number here. And 2 to the 4th power is 16. Minus 2, and once again, it's a negative number you have here raising to an odd exponent. Your answer is going to be negative. So negative 2 to the 3rd power is going to be negative 8. Then you're going to have now 7 times negative 2 is simply going to be negative 14, and you have plus 3. Further simplify this, and we will have negative 64 plus 48 plus, this is going to give us positive 16, and you can do this, which is negative 14 plus 3, which would be negative 11. So negative 64 plus 48, that is going to give you negative 16. 16 minus 11 is going to be plus 5. So P of 2 is going to be negative 11. So you notice that P of 2 is negative 11. It is same as our remainder that we had there. So now we can conclude that our remainder is equals to P of C. Since the remainder here is negative 11, x plus 2 is not a factor of this polynomial, because even though you have P of C, it's simply saying that you need to have x minus c, right? And x minus c, which would be the factor in a sense. So we have x minus, and our c value here is already negative 2. So this is a reason why you can say now x plus 2, right, is not a factor of p of x. Therefore, the factor theorem did not hold for this polynomial. Only the remainder theorem hold for this polynomial. In conclusion, now that you have seen both examples, you can now walk away with a greater understanding of the factor theorem and the remainder theorem. If you have 0 as the remainder, that simply means that the factor theorem holds, and therefore that factor, which is x minus c, is definitely a factor of the polynomial. But if you have a remainder such that any number, whether it's greater than 1 or less than 1, because it could be a negative number but not equal 0. So once your remainder is not equal to 0, then you can conclude that the remainder theorem holds if that remainder is equal to P of C. So after you've evaluated P of C, and if it is equal to the remainder, then the remainder theorem holds. I hope that you no longer have any doubts swirling in your head, and you can go ahead, share this video with your friends and family members so they too can have a better understanding of the factor theorem versus the remainder theorem. We don't want to have doubts swirling in our head. We want to have a great understanding so that we can master the concept in math. Thank you and see you soon. Bye now.